Ladies and gentlemen of Algebra 2, welcome to room 15 where it never ends. Even when we have a couple people gone today, but we just, well actually one person gone, right? Just Logan. All right, graphing cubic functions. So we're getting to chapter 6 starting today. And essential question, how are the graphs of fx equals a times 20x minus h cubed plus k and fx equals 1 over b x minus 20x minus h cubed plus k? And basically what I like to do is, and how are these functions related to the graph of f of x equals x cubed? And have you seen this type of format before in this class? Yes, you have.
Yes.
What other types of functions have we used for this general type of format? Two other kinds by this time. They were last semester. What other types of functions did we have this for? Two of them. No one? No takers? Okay, I'll show you what they were. We had absolute value function. We did this. Remember that? Absolute value function. What other kind of function did we do? Remember this? You should remember this. So what kind of function is this one right here with the squared? What do we call that? You should know that. Should know that from Algebra 1 and from first semester Algebra 2.
What's it start with?
Starts with a cube.
Quadratic.
Quadratic, okay? All right. Quadratic. Everybody should know that. How come people didn't say that out loud first when I asked the question and saw that squared? Where do we get the word quadratic from? You don't remember where you get it from? Okay, it comes from the Latin word quadrado. Quadrado, which is the Latin word for squared. So that's where quadratic comes from. Okay, now for cubic functions, we have this one right here. We have f of x equals a times quantity x minus h squared plus k. So what do these parameters do for this function? There are three parameters basically. There's this a, there's the h, and there's the k. What role does a do h, a and k perform? What do those things do? What do those things do? Now, our real Logan isn't here. Logan is usually one to speak out, so he's not here. So that's something for this class to overcome. But I need you to overcome it. If Logan's not here, we've got to step in his absence. What do these things A and H and K do? And Gio's looking at his notes, so that's good. What do these things do?
Is the K the y-intercept?
So the K is not, is the K the y-intercept? No, it's not, but it's closely related to the y-intercept. Okay, so it looks like it. If we had, I think where he's getting this, if you had this like y equals mx plus b, you'd have the y-intercept. Or if you had this equation in standard form, what you'd have f of x equals ax squared, ax cubed plus bx squared plus cx plus d. In this case, d, in this standard form, this last number here would be the y-intercept. But it is not in this case because you have to concern yourself with multiplying all this through. But it's sort of kind of related to the y-intercept, but not exactly. But what does what does it do? What does it do? By the way, I'm just going to write y-intercept here. Okay, what this does, this k, it translates the graph which way?
Up and down?
Up and down, exactly. And we're going to go over examples of that here shortly. What does the h do?
Is it left or right?
H will translate left and right. Okay, this is not a new thing, is it?
No.
We've talked about this by this time at least twice before, right? For absolute value and quadratic functions. And lastly, what does this A do? What does A control? A controls two things. What does A control? Now another hindrance we had for this class is we had another good student in this class transfer over to first period, Tyler. Okay, he was helpful too for this class, wasn't he? Anyway, what does A control? Okay, A controls the width or narrowness of the graph. Of graph. And how does it control that? It controls it by, and it does vertically what? By vertically stretching or compressing, right? Thank you. Okay, one more thing that A does. There's one other thing that A does besides vertically stretching and compressing. What is that one other thing? Anybody? It's another type of graphical transformation. Okay, I'll just start writing it and you tell me what it is. If or when, if A is less than 0, what happens? The graph is what? The graph is reflected about the x-axis. Okay, now you guys, seriously, you guys should have come up with more of this than what I had to drag out of you. Am I right about that? Am I right about that? Yeah, Caitlin's nodding a little bit. Yeah, and I know some of you knew some of this stuff. I appreciate Dustin and Seth and others who commented on it, but you really should know this. And it's going to be the same. We're going to have this for rational functions and exponential functions, and maybe if we get to it, logarithmic functions. So it's going to be the same pattern with this A and this H and this K. It's all similar. It all ties together, performing the same type of thing. Okay? Let's and then we have the state standard. analyze key attributes such as domain, range, intercept, symmetries, asymptotic behavior, maximum, minimum given an interval. So we're going to go over pretty quickly what this is here. Graphing and analyzing f of x equals x cubed. And it's really from where you're sitting here kind of hard to read. For me, who was recently had a prescription, my eyesight has been rated as 20/15 from a distance. You know what that means? You know what 20/15 eyesight is?
Is that good?
It's better than normal. Normal is 20/20. 20/15 means that I can see at 20 feet what a person with normal vision can see at 15 feet. That's how good my vision is from the distance. Corrected with contact lenses. Without contact lenses, I'm actually going up here to be able to read it. Okay, I can go up here and read without contact lenses. But what I'm saying, and another thing, is I'm closer to the board than most of you too, right? So that's another issue. Okay, so here we have this thing that says complete the table and graph this, and I copied this from your book, which is right there on the shelves. So if we plug in for y equals x cubed, we plug in -2, what's -2 cubed? -2 times -2 times -2 is -8. And then we have -1 cubed, which is -1. -1 times -1 times -1. If we plug in 0, what do we get? 0. If we plug in 1, what do we get? 1. If we plug in 2, what do we get? 8. So basically, that's all we have room for on this graph. So the points are like this. And if we draw the curve that connects these points, the curve's going to look something like this. Thing jogs momentarily horizontally at the x-axis at the origin and goes up something like this. So that's basically what it looks like. And so what is the domain of this? Well, it's going to be all real numbers, which is going to be in interval notation like this. What's going to be our range of this function? Well, range is also going to be all real numbers, isn't it? Now, from end behavior, as f of x approaches infinity, what is it? As x approaches infinity, what does f of x approach? What's this function doing? Going. Which way? Up. So as x approaches positive infinity, f of x approaches positive infinity. As x approaches negative infinity, f of x approaches negative infinity. So that's characteristic. Zeros of the function, we have x equals 0. That's the only 0 of the function. Where the function has positive values, well, the function has positive values where x is greater than 0. Where does the function have negative values? Where x is what? Less than 0. Where x is less than 0. Or sometimes you'll see it like this. Or on, meaning on the interval of negative infinity to greater than negative infinity to less than infinity. Where is the function increasing? Where is this function increasing? Okay, let's go down. Where's the function decreasing? It says the function never decreases. So where's the function increasing? If the function never decreases, where's the function increasing? Okay, function is increasing everywhere. Sometimes you'll see it as written as for all x. That's another way you'll see it written sometimes. Everywhere. Or sometimes you'll see it on, meaning on the interval of greater than negative infinity to less than infinity. And so finally it says the function is the function even, and it's hard to see it here. For even, what it means, f of negative x equals negative f of x. No, excuse me, that's going to be odd. Equals f of x. Yeah, that's what it is. Got to think through these things. Okay, or is it odd? Odd's going to be, definition of odd is f of negative x equals negative f of x. So which one is it going to be, even or odd here? And I've been doing it, I've been talking about this. Talk about it more with the right? Odd, even. Okay. When you guys were out on the field playing football, the cheerleaders were in the stands. They were going odd, even. So is this one here going to be odd or even?
Odd.
It's going to be odd, right? Odd positive is behavior. And it's odd, according to textbook definition, because f of negative x equals negative f of x. Odd, because it has the thing wrong here. But anyway, basically this is what it looks like, and if you go ahead, this is what a table view looks like. Another thing you say is this has 180-degree rotational symmetry. That's another way of saying this. So in a calculator, what it looks like is this. If we have x cubed and we graph x, fx equals x cubed, that's what the graph looks like. We go to table view. This is what f of negative x equals negative f of x. So what's f of 3? 27. What's f of negative 3? Negative 27. So f of negative x, so f of negative 3 equals the negative of f of x. So you see that kind of orientation in a table view. And then in first period I had a good follow-up question. Well, what does an even function look like? Well, an even function is going to look like this. If I make this x to the, say, 6th power, it's going to look like this. So that will be what that looks like, right? Odd, even. And then you look at the table view, and this is what the table view looks like. F of negative x equals f of x. See that? And then I had a good follow-up question too from, oh, it's Braden, yeah. What if we make this negative? What does that look like? Oh, he asked, can you have a negative one? Yeah, you can. If you go to second insert, put a negative sign there, and it looks like this, the graph looks like this, and the table looks like this. This is for an even negative function. Anyway, so that takes care of that. Now we're going to look at some types of transformations of this, and then we'll start some exercise set today. So explore 2, predicting the transformations of this graph of x equals x cubed. Predict the effect of the parameter h on a graph of g of x equals x minus h cubed for each function. And so the graph of g of x equals quantity x minus 2 cubed is a what of the graph of f of x? And is that going to take this thing right, up, left, or down 2 units? And when you get to the exercise set we're going to start working on today, it's assumed you're going to have a calculator to help you with these things, most of them. So what does this x minus 2 in parentheses do? Which way does the thing shift?
Left.
It is a translation, I will say that, right? Which way does the thing translate? Translation is a translation of the graph of f of x, right, up, left, or down 2 units.
Left. Or down.
If you said left, you would be wrong.
Down.
If you said down, you would also be wrong.
To the right.
It'll be to the right. Why is that going to the right? Okay, we've talked about it a lot. I don't want to dwell on it anymore. Guys, it should be ingrained in your algebraic intuition at this point. Okay, the graph of g of x equals quantity x minus x plus 2 cubed is a what? It's a translation which way? It is a translation of the graph of f of x, right, left, up, or down?
Left.
It'll be left. Okay, good. Did I sing you the one? Did I sing you the Merry Algebra 2 Christmas song?
No, you didn't.
Okay, I'll sing it to you because you've been educationally deprived if you haven't heard that yet. But actually, this one here, it was actually a pre-calculus song, but I changed the words to make it Algebra 2. I don't think I need cake for this one. Okay. Have a merry Algebra 2 Christmas, but remember Romans X and Rangers 1. Use your cell phone for refuge, book your codes, but never text in class or get a big fat zero. X plus moves to the left, and x minus to the right. Let's say that again. X plus moves to the left, and x minus to the right. Does that make? Let's hear it again. X plus moves to the left, and x minus to the right.
Got it.
You can solve by graphing to get your solution right. Our cosine equals x, and our sine equals y. But never touch that thermostat or you will die. Very cheery Christmas song, don't you think?
Yeah.
Has a good ending.
Especially the ending.
Where? That's a good one too. But anyway, x plus moves to the left and x minus to the right. Right? Well, you knew that, right? Or should know that. That's okay. Okay, now we're going to look at the k. And here's a k right here. The graph of fx equals x cubed plus 2 is a what of the graph of f of x? Is a what? What does a k do? That's what's asking. Okay. Is a what? What do we call this? Is a, starts with a T. Word starts with a T. Somebody said it, translation. And which way are we translating? Right, left, or up or down? Right or up or left or down?
Up.
It will be up 2 units, very good. The graph of g of x equals x cubed minus 2 is a? Translation, which way?
Down.
2 units down. down 2 units, okay? And we did the same thing for the other types of functions, right? For the absolute value, for the quadratic functions, we did all that, right? Predict the effect of parameter a on the graph of g of x equals ax cubed for each function. The graph of g of x equals 2x cubed is a what of the graph of f of x by a factor of what? So what do we call this? The graph of g of x equals is a what? Okay, I talked all about this right here when we did all this. I talked all about it right here. Okay, just 20 minutes ago. So what does this thing, what does that A do? Yeah, it controls the width or narrowness, But the kind of transformation we call it is a okay. We're going to get to reflection here a little bit, but this is it's called a vertical stretch. It's a vertical stretch. By a factor of 2. That's stretch. ETCH. By a factor of 2. Thank you. The graph of g of x equals negative 1/2 x cubed is a what of the graph?
Compression.
Vertical compression, okay? By a factor of? By a factor of 1/2, as well as a what? Starts with an R. Reflection about the x-axis. Across the x-axis. Okay? So those are the things we're going to go over, and we're going to go over some exercise. I'm going to hand these out to you to start working on today. And number 1 is, I'll show you what number 1 is.
Mr. G, did we turn yours back in here? This is the one I was missing, is there? This one?
Oh, really? Yeah, let me see here. I'll see what the grade book says. Because I didn't miss any grades on the front. I'll go take a look. So what I should do, number 1 is the same thing pretty much that we went over in class. We filled out. I'm just going to flash show it to you here. It's this thing right here pretty much. Okay, so I want you just to work on that with your neighbors for the remainder of the class. And then